Okay, so the easiest way to do this kind of question is to do, well, there's two ways to do it. Okay, let me show you both of them. In Canvas, this is a binomial distribution, right? And in fact, why don't I do this part of it before I leave? We know, and maybe I'll just do it this way. And then I'll show you the other way. So the one way to do it, Dr. Stevens goes into this, he talks about how if there's certain conditions that happen, if 0.184 times the sample size of 400 is bigger than 5, we can use this method. At least we can potentially use it. So I'm going to go ahead and calculate that because I need this number later on. So 0.184 times 400, I'm getting 73.6. And then we also have to check that 1 minus 0.184, which is 1 minus 0.184 is 0.816. We need that number later on too, so that's why I took the time to do it. So times 400 is 326. Well, Dr. Stevens says if you do these calculations and both of these are bigger than 5, you can use this situation, use this techniques. And the technique is we're going to calculate a z-score and then see if it's more than 2 standard deviations away from the mean. I'm seeing so the mean. So is this a binomial distribution? First off, I should have asked that question. I see a fixed number of trials. Yep. I see a yes/no situation. Yes, I had a headache. No, I didn't as a side effect. The probability of anybody having a headache based in the long run is based on that study result. And so the probability stays the same from person to person in the long run. And then whether I have a headache or you have a headache doesn't have any effect on each other. So that we're independent probabilities. So it's a binomial distribution. So because it's a binomial distribution, I can find the mean of the binomial distribution by doing n times p, and that's what I did right there. So that's the mean is 73.6. To get the standard deviation, we do n times p times 1 q, or 1 minus p, and then we take the square root. So we've already done n times p. That was a 73.6. So 73.6 times 1 minus p we already did too. So that's 0.1816. We're going to multiply those two numbers together and get the square root. Let's see. So I'm going to do 73.6 times 0.816, then take the square root of that. I'm getting 7.75 if I round. Okay, so now we're going to do the z-score, and the z-score we're interested in is 86. A number we're interested in is 86 minus 73.6 divided by the standard deviation of 7.75. And when all said and done, this works out to be 1.6. So it's not more than 2 standard deviations. So this is it is unusual to see 86 people out of 400 that had experienced high side effects. So a mild side effect is often what they'll call that, right? You've seen the ads. Why is this part so important that I can do this? I mean, why did I have to do this checking to see if it met the conditions? I mean, why is that important? Well, I'm going to show you 2 calculators here. I hope you can read underneath all my scrawl because I really don't want to lose that. The first one I'll show you for this, because of this application, is this. I'm in Canvas, I'm on modules, I'm on course resources, and you see this page. And this is going to be your best friend here. This one here is going to be your best friend during week 7. But for this question, for this week, we're going to click on that histogram applet. And I'm going to type in my 400. Maybe you've seen this. Maybe you've seen my other videos where I walked you through this. 0.184, right? And there we go. Lo and behold, look at that. Don't we have a nice symmetric distribution? In fact, we'll learn it's a normal distribution. And because it's a symmetric distribution, we can use the mean and the standard deviation to describe center and spread, which means we can use a z-score and the two standard deviation outlier tests to talk about outliers. Okay. So that's one way to do it. And if doing it this way is actually the best way to do it. You do the check and make sure that you get that symmetric distribution. And then this is the easiest way to do it. It'll pay off dividends later on in the course, knowing how to do this. And then the other way to do it is if you go here and click on that binomial probability calculator, that'll open up this web page. And I think I've already done this. Yeah, I see I already did this earlier. Well, maybe I should refresh the page and show you in case you haven't watched any other videos. Oh, come on, computer, you're so slow today. Okay, so I typed in the probability of success, which was the 0.184. I typed in the 400, which is that. And size, then 86 was our desired thing. And then I'm going to click calculate. And then I can decide which one do I use. Well, the mean is 73.6, isn't it? The 86 is bigger than that. So I think what I'm trying to do is here, let me find that. I think what I want to find is, well, here you can see it. X is 86, right? C, and let me do this. That way you can compare the two calculators. Okay, see how it's shaded in that red area? That's the probability of getting 86 or more people that have a headache as a side effect. See how it's doing that tail area? And that probability right there is bigger than 5%. So we can't say it's unusual, which agrees with our standard deviation test, right? So we don't even need to know if it's normal, if it's a symmetric distribution to do this, as long as we know it's a binomial distribution. Just to so you can see, you see how this last one, X is greater than or equal to X. So that's doing that 86 or higher. If I was only interested in more than 86, I would use the next one up. Either one of these shows that it's not unusual. So, okay, hopefully this helps you do these kind of questions. You got one on it on the quiz next week. I probably have already said that. I'll get this uploaded.